Welcome back to the continuation of Lesson 2 in Tutorial 4. We are pulling a timeout transition here, and it's just to show an example of how you can involve time some of the different ways. We're going to assume that in the on3 state, so that's the red one here, maybe we only want it to stay in there for 5 seconds. We could say that, the flashlight will overheat if it stays in that state for too long. It's just an example here. So after that 5 seconds, we want to transition from on3 back to the off state. So that's our goal here. So yeah, we could implement this many different ways, but we're going to use polling to check guard conditions. Now, this is really important in embedded systems and game development, and so that's what I wanted to show off here. It's important to note that state machines are purely event-driven. They just sit there waiting for you to feed them the next event. So now in our case, we actually do want to poll for certain conditions. So all we have to do is send the do event to our state machine at the rate that we want. So you have full control over how and when your state machine runs. Going to keep going. We're going to add a transition to the off state. We already have the simulation set up, like it says here. The index.html JavaScript is already set up to dispatch the do event to the state machine every 500 milliseconds. So again, we could do fancier timing where we actually get the current milliseconds and compare it to an old amount and figure out how much time has elapsed. But we'll keep it simple for here, and because we know that our do event comes in at 500 millisecond intervals, we're just going to wait for 10 of those do events before transitioning, just to keep the complexity nice and low for the tutorial. So this is what we got to do. When we enter the on3 state, we're going to reset count to 10, or 5 times 2, and then add a do event to decrease the count, and we order that so that this do event happens before this transition is checked here. So let's go ahead and do that. I'll copy and paste this in here. Right, let's head back over to here. So on3, editing that. If you had formatted text enabled, pasting in here sometimes might be a problem, but without formatted text generally just works. And then we also want to say, on our do event, we are going to take count and decrement it. But we also wanted it to happen before the other transition is checked. So now we're going to draw an arrow. So we can draw it like this over to here, and you can pick any one of these. I'm actually going to redraw this. If you look at the wiki page for all the different tips, this blue anchor is that it'll kind of move around as the edge moves. I'm going to draw it just kind of simply instead, like this. We'll pop it up there. I'm going to drag it out to the side, and we're going to give it that guard condition. So I hit F2, and we're going to say if count is less than or equal to 0. And I'll drag it down to here. Put it down next to the state that owns that behavior. So we'll save. And let's compare it to what we were looking for. So we've got our do event, our count minus, and our transition to off. So I think that looks good. And again, yeah, so for convenience, Statesmith will implicitly assume the do event for any behavior or transition that does not have an explicit event associated with it. So in this case here, because we don't have the do event written there, it's going to assume it. We could write it in. That is the equivalent of what we had before, but it's just a lot of extra typing, so we do it implicitly. Okay, so that part is good. So now what we're going to do is we're going to open up our terminal again, run it, and we should see it work. Okay, let's head back to our simulation. We'll refresh the page, and again, this simulation, the index.html page, is smart enough to detect when our state machine listens to the do event, and so it's sending the event for us already. It's not something that you may normally do, the automatic detection. It's just something I put into the tutorial to try to ease the amount of work that you have to do to wire everything up, just to keep the flow kind of simple. So increment, we're going to hit it 3 times. We're going to transition into the on3 state. And then when we're in the on3 state, we should see this one count from 10 down to 0 and then transition. So 1, 2, 3, here we go. We see it's counting down here, and then we should kick off to off. Boom, there we go. We just did it. And actually, before we go too far here, I want to show you something cool about the simulator. I just opened the index.html page over here, and I'll bring it up now. And remember how we didn't write do beside this transition from on3 over to here? Well, the simulation shows it. So in case you're ever wondering, I think this is kind of nice that it shows what's actually happening, not just implicitly shown, right? Here, yeah. So implicit here, simulation shows it explicit. And let's actually go through this a little bit. I want to show how these guard conditions work in the simulator. Now, the simulator doesn't actually run any of your code. And because of that, well, it basically can't without doing some sort of like, I don't know, crazy back-end compiling, depending on which language you've picked. Like if we've got Python code in here and you're running it in your web browser, technically possible, but you know, a lot of work. So this just kind of tells you what it would do. It says, hey, I would have run this function off. When you hit inc, it enters it and then says, I would have run the code blue laser. When you enter this one, it says, I would have done yellow laser and set count equal to 0. It doesn't actually know what the value of count is here, like the variable. We might improve that sometime in the future. So now when we hit inc again, we're going to get a prompt here asking how to evaluate the state, because statesmith, the simulator, doesn't know the value of count. So here it says, evaluate the guard for on2 behavior, inc count greater than equal to 3, transition to on3. So press OK to evaluate the guard is true, or cancel to say it's false. So, you know, if we were keeping score here, we would have to do this 3 times. Like we could kind of keep track of it manually in our head, but because it's just a simulation, and if you just want to exercise this transition to get to on3, who cares what the fake count value is? You can just make it happen. Right. And now over here, you can send the inc event, nothing's going to happen. Here's where you have to send the do event if you want to check this transition. So we'll send the do event. And again, because we have a guard condition, it's saying, hey, is count greater than equal to 0? Yes or no? We'll say yes. And yeah, that's basically how the simulation works. We will eventually improve it to make it more aware of state machine variables, but for now, you have to tell it when to transition or how to evaluate guards. Okay, so we did our pulled state machine here. There's just a note here that if we wanted something like this guard condition to apply to absolutely any trigger or any event, there's something called trigger maps that you can do that with. Okay, getting to the next exciting and big part here. We're going to finally wire up the off event. If we go back to our simulation here, we'll notice that the off event hasn't been wired up. We don't have an event handler for that yet. So we're going to go ahead and do that. So first thing we're going to do is we're going to add an on group, and then we're going to move the on 1, 2, and 3 states into it. And there's an important thing we're going to talk about when we do this. So we're going to zoom out, and I'm going to copy this. I'm just going to hold control, and if I hold control, I can kind of move it around anywhere as a cloning. If I copy it, or sorry, if I select it, hold control and shift, it restricts my movement. I'm going to resize this state so that it's large enough for on 1, 2, and 3. I'm going to rename it to on group. Oops. I'm going to delete the handling up in here. And now I'm going to go ahead and, you know what? There's many different ways to show this. One way is I'm going to move this in front, send it to the back. And so visually, this is problematic, and this is what that node is talking about. We can just fix this temporarily here quick. So draw.io allows you to draw things, like to draw designs that make it look like these belong to the on group state, but they don't actually. So if we run our code generation here, it's going to tell us non-related nodes overlap. and it gives us a little bit of information about which nodes overlap and some tips on how to fix this issue. Basically, it's this problem here. Those states don't actually belong to to the on group. But what we can do is grab them, and now that, I'll select them one at a time. Select them one at a time here. Now that they are over top of this, if I move them, do you see how the border around on group goes green? Now when I drop them, they will become part of on group. So now we're good. All that issue is gone. Another thing to note too is, you remember how this edge was kind of messed up like this when we moved it? You could manually route those edges, or because it's a rectangular edge, we can go over here and just reset it to orthogonal, and it basically kind of reroutes it, and we can just easily bump it back out to where we wanted. Another thing that you might want to do is sometimes these edges get kind of annoying when they're orthogonal or those kind of rectangular. Sometimes it's helpful to put them just straight. So, just basic draw.io tips. Okay, so we've got our composite state here. Now all we have to do is wire up an event from on group to off when we get the off event. And that's it. There's one other thing that might happen too. You could move these around. You could also get rid of the background color if you wanted to. Just options. I'm not going to worry about the visual styling right now. You can tweak to your heart's content. But sometimes you'll have arrows that, like if I bring this to the front now, like this, you see that our arrows disappeared. That's something you should, keep an eye out for. If that happens, you can either send this to back or select arrows. And actually we could go edge, select edges, grab all of them and say, bring them to the front. So just something to keep an eye out for. Draw.io lets you draw many different things. Okay, so I think we are good now. Let's go check in with our tutorial here. Yeah, it has some of those tips we just talked about. Orthogonal, adding the transition. And yeah, let's go ahead, run our code gen. We are almost there, my friends. At least I hope you're my friends. Please don't be my enemy. Okay, I can't think when I'm being stupid. All right, now we've got our simulation running. Let's get into on2. We should be able to send the off event and have it go right back. Perfect. We'll get into the first one, off works. We'll get into the third one, the red one, and off works properly. Okay, so we have done it. You can color this to your heart's content. I'll just show a quick little bit of how you can do that. We won't spend too much time rearranging things. But if you wanted this one to be red, click on style, boom, it's red. Want this one to be a little bit more muted? Let's go find this one. That makes it look a little bit more muted. If you want all of the off, or kind of like the things that dim or either make it go off, to be a bit more prominent, we could increase the weight of those. The arrowhead looks a little bit silly when you make them bigger, so we can make the arrowhead that standard one. You can basically color it to your heart's content. Statesmith doesn't really care about the styling at all. And that's it. So we will pick up next in the lesson 3.